All right, we're back. We're still in Notes 10, page 3. I think it's Notes 10. Yep, Notes 10, page 3 of Math. Nope, of Calc AB. It's going terribly. All right, let's see if we can do this. So there's 3 important theorems, all of which are called value something. There's intermediate value, there's mean value, and then there's extreme value. And I would say in order of importance, they go mean value, intermediate value, extreme value, except extreme value is kind of the one that makes everything go. Sort of. I mean, I guess intermediate, I don't know. They're equally important. I think you find yourself using the mean value theorem most, then intermediate value, then extreme value. Extreme value is maybe the least calculus of all of them, maybe. The extreme value theorem just says, but this is a big deal. Every function that is continuous on a closed interval, continuous on a, continuous should also get it. Continuous on a closed interval has an absolute maximum and an absolute minimum. Every function that's continuous on a closed interval has an absolute maximum, absolute minimum. So it can happen more than once. The absolute maximum could be 50, and there could be 25 different x values that give you 50. Everything can be the same. It could be a horizontal line. A horizontal line, the absolute maximum and the absolute minimum are the same, and they happen infinitely. They happen at every x value. But the extreme value theorem is super important, mostly because it gives us what's called the candidates test. That's not a highlighter. But first, let's see if we really get it. So what we're saying for there to be an absolute maximum is that there's a number c in the closed interval from a to b. So this is an x value. An x value right here. Such that f of c is greater than or equal to f of x for all x in the interval. Similarly, there's a number c in the closed interval such that f of c is less than or equal to f of x for all x in the interval. So you don't use it all that. I'm of the opinion you don't use it all that much. It does show up on the AP exam from time to time in multiple choice for sure. So we combine the extreme value theorem, the extreme value theorem with critical points to come up with a way of always figuring out the absolute max, the absolute min of a function on an interval. And that method is called the candidates test. So candidates test might actually be my favorite test to use. So the candidates test says, if a function is continuous on a closed interval, then its absolute max or min must occur at an endpoint or a critical point. So it's almost the extreme value theorem, but then it throws in or a critical point. So that has to happen. So the way we use it is first we confirm that f of x is continuous. Usually you just say like f of x is continuous, or you say this doesn't apply because f of x is not continuous, and then you say why, whatever. We're going to find the critical points on the open interval. Then we're going to evaluate the function at the endpoints and the critical points. And we just look, the biggest y value that we get is the maximum, the smallest we get is the minimum, and you are done. Like the only real calculus part, I guess, is the critical point. So you're gonna have to find the derivative, set it equal to 0, blah, blah, blah. But that's about it. So I'm gonna actually stop this here, and in the next video on the next page of the notes, we'll probably use it. I don't really know. But anyway, I will see you there.